welcome to this lecture, and in this lecture we will continue with the concept which we studied in the previous lecture about potential energy and its relation with force when it is related with respect to distance. And further we will also study the inverse process of differentiation. Is there anything called inverse process of differentiation also? So if I recall, we were studying that du by dx and negative of this is equal to force. And if we take a graph, suppose like this, the potential energy may be dependent differently with respect to the distance. So let us take that potential energy is dependent with respect to x like this. This is the situation. Later on Pawan sir will explain just now that what is actually the condition physically. So basically when you see this graph of potential energy with respect to x and you draw a tangent at a point P, then you will get some angle which it makes with the x axis, and the tan theta of that is the slope of the tangent, and this is basically du by dx which we studied earlier. So the force is negative of this. Why is it negative of this? Pawan sir will explain just now.
So you can look this situation in two different cases, whether you study the value of potential energy that can vary with distance also. So in those situations we will discuss how this negative sign will implicate the relation of force with the potential energy, and the two are very simple conditions that you must have learned earlier also. Let us first discuss this condition in case of gravitational force. So as we know, when we move in the vertical upward direction, the potential energy increases. So if there is a point 1 and a point 2, we can simply say that the potential energy at point 2 u2 is greater than potential energy of point 1, and the difference is given by mg into h, where h is the difference of height between point 1 and 2. Now what is the meaning of this negative sign here? This negative sign simply represents that the force is in the direction of decreasing potential energy. That is, the force will be along u2 towards u1, and as you already know that the gravitational force mg always act in vertical downward direction, and this is what is being represented by negative sign here. We can see another case also. As you know that when we stretch or compress a spring, then this spring stores some amount of potential energy, and the value of potential energy is given as half k into x square. So if we increase the elongation in the spring, then the potential energy will increase, but the spring has a tendency to restore its normal position, and to do that, the spring will apply a force in the direction opposite of in the direction in which potential energy was increasing. So in both these conditions, you can easily understand that the negative sign represent here is the decreasing direction of potential energy will give us the direction of force applied by the system in that case. And this is how the differentiation will give you not only the value but also the sense in which the force is acting. So now Subbu sir will give you detail about some various other things related to the differential and inverse of differential.
First I will try to put this mathematically so that you can relate this one and this one more clearly, as a lot of things has been cleared here in both the cases. This is the first case, let us say, and this is the second case. So there are two cases over here, and in the first case we have taken the potential energy as mgh, as sir has already told us that potential energy, a change in potential energy is mgh. So let us suppose the potential energy at this point is mgh, and on the ground it was 0. At the ground the potential energy
as a reference point from where we are measuring the potential energy.
Yeah. So we are taking a reference point as having a 0 potential energy. Now if I differentiate this u with respect to h, what will happen? That mg are constant terms. So they will simply come outside and it will become mg dh by dh, which will become mg. And if you remember, mg is the force of the gravity on an object of mass m.
Yeah.
So basically force is equal to mg, and we have to add a negative sign here to show that the direction of force is downwards but the height was upward. We have increased it upward.
Yeah.
So this is first situation. If you also see the situation of a spring, so here as sir has said that this is the direction in which elongation has happened. Let us take x here instead of h, and the force is in this direction. Again, if you apply this formula of potential energy of a spring, so you see that u is equal to half kx square. Now when you differentiate here du by dx, it will simply become half k, and the differentiation of x square is 2x. So this will cancel, it will become kx. Now the force will become minus kx similarly. So basically here again the elongation is here, but the force is trying to bring it at the
Restore the normal position.
Restore the normal position. So what are the slight difference between the graphs of these two? So if this is seen, so actually this is the graph of this one actually, because here the x square term is there. So this is a quadratic form of the graph, and the tangent is actually minus kx, which is linear graph. We will see this in coordinate geometry more elaborately, but for some understanding of the concept, that this is a situation of a spring. If we see that this is a situation of a spring where potential energy may be half kx square and the tangent is actually kx, that is the slope. And if we want to draw for the first case, then the graph would be something like this. Suppose you have a straight line like this, which is the potential energy, and here there is h. So here it is a straight line mgh, which is already linear, not quadratic. Here h has a power 1, there x was having a power 2. Now when you differentiate it, you will get mg. That means the slope of the tangent at any point is always same, which is a constant. It does not depend upon h. So basically you can in layman language understand that as you keep on stretching a spring, you have to apply more and more force as you are going away from the equilibrium. But in case of height, when you are taking something upward, you have to always put a constant force. The force is always constant, it is not increasing with height. So this is what we have, the relation of differentiation with respect to the physics. Now the most important part here which we are going to start is basically a concept of integration, because if we are seeing here that potential energy on getting differentiated gives force, so can we also say that is there any way in which we can obtain potential energy from force? Okay, so if we are saying that du by dx is giving us a value of force like this, or we may also say that velocity is displacement derivative with respect to time. So is there a way such that potential energy can be obtained if force is given, or displacement can be obtained if velocity is given? So here now we will start the concept of anti-derivative, opposite or reverse of derivative, which we also call integration. Here we will study indefinite integration. Later on in some other lecture also we will study definite integration. So first of all, let me make you understand with a graph, and I'm not taking any other graph, I'm simply taking a graph of x square, y is equal to x square, or let us say y is equal to x. Okay, so I'm taking graph of y is equal to x. When you differentiate a function, suppose fx, you get x. Okay, now the question arises that what should be the function fx. So in that situation, as we see that fx is a function which you get differentiated to give x, So we can do some hit and trial, some manipulation. Suppose I am taking fx as x cube and I am differentiating it. So by differentiation it will give 3x square. So obviously this is not the function fx which we need, because the differentiation of fx has to be x. So if we decrease the power of x to 2, so dx square with respect to dx is actually 2x. So it has become linear, but there is a constant 2 which can be easily managed. So if we take this 2 not here, rather we take d of x square by 2 dx. In that case, this half is outside and dx square is 2x, so this would be x. So what we understood here, that yes, there is a function fx which is called x square by 2, which will be differentiated and we will get x. So now, is there a process here? We have done hit and trial. Is there a process from which we can directly write it? Is there a way? So what we can do, instead of doing this hit and trial, we can write this expression that if we want to get this one, so let us go this way and come this way. So fx is actually integral of x dx. This we can say, which simply means that fx is a function when differentiated gives x. So anti-derivative, this what we have used here like this is called anti-derivative, or we can also say that it is an integral. So integral of x dx is basically x square by 2, what we have seen here. So now after doing this, I will try to make you understand what indefinite integration actually geometry